Good evening, Internet. Hope you all are doing well. It is Rainydan back again with another scintillating episode of Let's Make a Puzzle Factory. Okay, in our last time, we were talking about whether or not the inventor and the antiquarian should be the right person to answer a certain question. And then let's see. We are also talking about. This is just sort of like a small detail that has to do with how we have been like building our city piece by piece, and then there's a little cruft here and there where not all of the patterns are totally consistent. We're looking to see if the antiquarian improvement that we made is actually going to do something. We asked hey, do we have some variant relationships inside of the catalog, and how do we want to structure that? And then we're hoping that that creates a memory and a recall. And then, yeah, we were also just talking about these sort of small details about formulas using each other. And then I guess what we'll find is where it took that next. Okay, we haven't used CAS. Um, sure. Let's kick off the index. Indexing. How are our other threads doing? Some log clock time has passed. So as usual, a lot of the stuff that we're doing is being carried on in the background by certain agents. I leave things running whenever I pull up the phone on the stream, then pick it up again, and we see where we're at. I hope you enjoy soccer. The World Cup getting started. Had a pretty exciting game with the U.S. I won't spoil it if you haven't seen it. But yeah, make sure to give U.S. v Paraguay a watch. Let's see. Where are we in the middle of a puzzle? Oh yes, this is the loops one, lasso, Naginawa. And if you'll recall, we're trying to figure out which cells inside of each one of these regions are going to be used. We're given the number, but not how many are used. And then the goal is that we're going to be drawing rectangles, and they can pass over each other or pass through each other, but they can't share a side. They can't overlap like that. I think we just got done arguing that we definitely can't draw a line down this way, closing off this, because then there's no way to pick two vertices of this 2 region and then extend that into. So the minimum rectangle or square looks like this. It's like a 2 by 2. And anything that we do starting here to take two vertices is going to have to extend down into the region below, and it can only take one vertex. So I think that we're guaranteed that we've got to go this way. And that means these would be vertexes, and that means these cannot because we're at this 2. This is a corner, and then we've completed our rectangle right there. All right. So now we've got this region down here with a 1. If this was a vertex, then this would be in a corner, and whenever we hit a corner, we have to go, you know, along the walls of that corner. So this one definitely can't be the vertex. It could be this one or this one. It's not super clear right now. This part down here is certainly suggestive that maybe we want to draw a rectangle down this way, but we don't know that for sure. If this were the vertex, then this and this couldn't be, and so this would be a corner. And it would go like this, at the very least. Well, we could talk about this rectangle right here. We can't extend it too far, right? We're into that same thing with only one vertex in this region. So say that we took, here, I'll draw this hypothesis in green, we'll erase it. Say that we took the line all the way down to here, right? We can't make this, it can't go any further because we've already used up our one vertex inside of this, region of one. But that would mean that we'd need to complete this rectangle going over this way. So we have this contradiction. Right? So we can't actually go all this far down. Our two choices are either come down one, and that would look like this, or come down 0. Now look what happens when we come down 1. We've used up too many vertexes inside of, I say vertexes, but these points along the way also count. We've used up too many centers in this 3 region. So in fact, we can't come down even 1. So we tried both. We tried the scenario of 2 and the scenario of 1, and they don't work. So we have to come down 0 more. And this makes a rectangle, which is cool. Now this sets the rectangle going, and we have this rule that 2 rectangles cannot share a side. So if this rectangle stopped right here, then they would share a side. So we have to keep going. Like so. Now we don't know if this is going to stop yet, but we do know that we've used up 3 points inside of this 3 region, and so that has to stop right there. I guess we can't be sure that there isn't another rectangle that goes. There might be an argument that you can't go to the left from here, but it is a little complicated. A little complicated looking. So this forms an edge of a rectangle. And the interesting thing about this one is that we definitely can't take it up, either 1 or 2, because no matter what, we'll have to go left or right from one of those, and that would mean that this rectangle would share an edge with this one somehow. So that kind of means that this is a corner. I think that's all. I think that's pretty solid. This is the one vertex in this region, and so this is also a corner. And we don't know if it goes down or not. But let's see what else we can see. We might need that argument that we can't go left on this one sooner than later. That would turn this into a corner. Hmm. I'm sort of looking at the bottom corner rectangle kind of like this. That wouldn't quite work because in order to we'd have 3 in this region. We can't make this one cross over to the right. And the reason why is that it would definitely, these are the left and right edges of this rectangle. It's kind of boxed in by these corners. And whatever rectangle we draw from here would definitely have to share a side with one of these, a side or a corner. Corners are also forbidden, right? They may cross at will but never share a line segment. Okay, I guess they could meet at a corner. I haven't been interpreting it that way, but if we glance at the solution, there's none like that. It says they may cross, but never share a line segment. I mean, I guess that means you could draw a little square like this and a little square like that, and that would be legal. But how legal? I don't know. So I shouldn't discount the idea that maybe this could go to the right. Otherwise, I was just planning to draw this segment to the left. It's not necessarily true that this one would be drawn down either. If this were in the middle of some segment, then the vertical lines wouldn't come through here. Okay. All right. Thread status. Antiquarian closed with substance. There are certain heuristics that we could use. Formalism class, constraint family, mechanics tags, plus some pro sibling flags, shared publisher name, single clause formalism diff, triple overlap alone over clusters. There's a 28 member Sudoku group, which I gotta say, it is the most popular one, I would assume. Certain other clusters have been found. Yeah. I think we talked about these. Where is the black go? Variant group. And then what makes it a variant? That's cool. I'm not sure what it means by take IV. Take 4? Smith closed with a blocker. Hmm. We need some certain families of techniques. It's talking about like I guess these would be solving techniques, right? Great. Yeah, we do want adult store maintenance. Yep. Inbox sweep. I think that this is potentially a thing that we're going to want it to do in the future. So it should be a formula, a business process to extend the technique library. What's it saying about the history search? Yes, the original pattern was extends, then it got refactored out. Cool. I'm glad that it's finally sort of learning from our earlier conversations. Maybe I should have tried to install this a long time ago. All right. Um, let's. Yeah. I liked your order just fine. I like your order just fine. Variant schema. Um, I think it's good to add this. Um, I think it's good to add this as suggested and refine it later if necessary. Variants provide us another way to think about expanding existing puzzles. And it will be good to have examples as we make our own puzzles and variants. Mm-hmm. Analyst leg. Does this request to extend the technique library rise to the level of needing a new formula? Or should it be a more informal communication? Request for work between departments. Perhaps we need to set the standard that this kind of request is okay. Then Smith could take the initiative to route it to the right resolver. This is sort of about whether or not the Smith should request this work from the analyst and whether the analyst should consider it in bounds in its capabilities and charter. And we're not just trying to get the request done, we're trying to figure out how to allow it to extend itself to make this kind of request and resolve the kind of request. All right. Once again, we're looking for insights. Can we extend this down one level? If we did, let's use our hypothesis color again. It would look like so. This would happen. We could only use one more of the two region. It can't be this one because making this corner. I guess we could even. I think we can eliminate this one anyway because it's in a corner, and if we made it a corner, right? When I say corner, I mean there's a sort of solid wall here on the outside of the puzzle and one in this unused space right here. So if this was a vertex, I can just make this inference right away. If this was a vertex, then we'd have to draw 3 lines inside this region. We can't do that. If this was a vertex, we'd have to draw these 2, which eliminates this one, but it's not the weirdest. If this was a vertex, it's okay. It doesn't hurt anything. All right, maybe let's continue our green hypothesis here. We extend down by 1. This and this aren't used. We can only take one more inside of this 2 region, so we can't pick this one because it would be a corner. It would fill us up to 3. So this would be a vertex for sure. It's not, it wouldn't be obvious. Well, this would have to go like so. Oh, this would be a problem then because it would go like this, and then it would have to go like this. And this 4 would, this 3 would have 4 vertexes. And that can't be. Yeah, so it can't extend down. I mean, we can extend this argument. I think it is exactly the same though. Yeah, it's the same situation. So we cannot extend that down any further. It has to stop right here. Now let's consider this one right here. This would be another corner, right? This one would have to stop right here. We'd have to decide if we kept going down or not. Oh, but no, this makes this into this causes the problem with the 3 again. So, I mean, I think that we argued ourselves into this, but we could also just argue ourselves into this right away. Or that this has to be used. Putting a dot here causes the 3 to get overloaded. If we put a vertex here, then it's also in a corner. Oh, I think we're stuck with this. We couldn't put a vertex here then, because it would be stuck in a corner. We can have one of these, but not both. This is a vertex in a corner now. Just noticed. This one too. Still working hard. No new formula. Codify peer-to-peer. Smith files a bead, slings it at analyst or at concierge. Yep, it's just bead sling mail. This is the peer-to-peer routing thing that we were talking about before. Basically, there's a choice that you have when you're trying to route work, which is if you think you know where it should go, you just send it there. Or if you would like it to go through sort of the central directory structure, if you think for whatever reason some other actor has more scope than you, then you should send it to them. Sort of with this sort of routing analogy, right? Like if it's one of your peers, then you just send it. But if you don't know where it goes, then you should send it upward. Yeah. Here. Just a short pause. Be right back. Okay. I really need to get that hold music. But anyhow, yeah, I like the charter standard bead that it's talking about. That will make sure that everyone knows how to route things peer to peer. The controller calls BD create on every block or close. And they invoke dolt remote v internally. It might be that we're behind in some versions and that we need to get some good ones. Sure. Let's do 1 and 3. Regarding routing, I think that's a good general addition. Maybe it should be factored as a template fragment, which is a gas city concept used for including common instructions and prompts. I believe. But either way, it would be good to enshrine peer-to-peer routing, escalate to concierge as the strategy. Okay. Yep. So it'll file a BD Oracle question. Okay, we can't draw this vertical line because that would create a corner right here, and this one can't fill both of these things. So if there is no vertical line, we could still believe in a horizontal line that went this way. Then this one has to keep going. And we're not sure if it's a really big rectangle that goes all the way over here, or if it's a small rectangle like this. Is this a corner? It sort of looks like it, like if it went up this way, then it would have to share a side somewhere along here. Because it can't just be meeting at a corner. If it went over this way, then again, it sort of has to share a side. It's sort of stuck in this corner. So I think this is reliable inference. If this is 1, then this is nothing. And this is in a corner also. We're not sure if this one or this one would be used. Well, if this one was used, then it would be in a corner here, something like this. It would cross or meet at a corner, I guess. And that wouldn't work because we'd have too many in that region. I think that we just reasoned that this can't be used. I mean, we're kind of seeing a solution kind of directly. Like, let me sketch it out here. Now, I think we're a little bit a ways away from proving all of this, reasoning toward it, but this does satisfy every region, I think. And we could double check against the answer. So sort of a cross, a 2, a 1, a 9, and a 12. Well, I said 2, but let's call this a 6. A cross, a 6, a 4, a 9, and a 12 from the areas of the rectangles. Interesting. Why did they have to? Oh, I think I see the error. It's this right here. This wasn't used in my little solution. Nevertheless, we got most of the way there. We could try to reason about this. This is bad because there you go. You're like no matter what, this rectangle is going to have to share a side with something. Like if this was true, then well, we can't have this. This would be like sort of a three-sided. No, there's no way that a three-sided thing on the edge can't share an edge. So we could infer that this has to go this way. We've created a corner, and then we've actually found the dimensions of this box. This creates a corner right here. Now I think it would be impossible to extend this one any further without sharing a side with this rectangle. It looks like you could make these ones meet at a corner, and then right here. If it's legal to meet at a corner, then that would solve the puzzle. Right? You could do this. They would meet here. You could draw this one. So if meeting at corners was legal, I think it's not though. If we assume that meeting at a corner isn't legal, then this one is stuck. And then this one can't go meet these at their corners. And it's sort of boxed in. But yeah, it's not super explicit in the rules. Now let's look at what happens if this is empty. Well, both of these are corners. This is also a corner. This one has to get up to at least here. That means they have to cross. That means this one has to come up here, and that means these have to cross. But they can't, because you can't get to this next dot up here. So we would infer that this one has to be filled and this one can't. This is a corner. These are both corners. We can't complete down here, so we have to keep going across. And this is a corner. And there's our square. Yeah, I really do think that we need to have this can't touch at a corner thing. Or else, yeah. Or else we had that alternate solution, I think. Okay. Alrighty. Great. It just wants to rest. You have some parallel threads running. What is the status on artifact refactoring? It's hard to keep all of them in my mind too. I think we are like working on like 4 or 5 work streams. Maybe I should call them work streams. That might, make them better. It might be a neologism that we could mutually understand. Are we waiting on anything? I don't recall. Okay. Non-do. The N-R in Japanese, kind of hard for me to say. Nando. All numbers in a region must be equal. The given number indicates how many cells in this region contain a number. So there are 3 3s in the 3 region. The same numbers must not be orthogonally adjacent across region boundaries. Numbered cells must not cover an area of size 2 by 2 or larger. So no 2 by 2 of the same area. Oh no, of any numbered cell. And all numbered cells must form a single orthogonally contiguous area. So this has similar rules to some of the puzzles that we've done in the past. Okay. Have we got to have one in the ones? I mean, we've got to have two twos. We're gonna have five fives. So for instance, we can't fill in all four of these, and so we have to leave out at least one of them. But that means both of these would be fives. Then we have to leave out this one by the 2x2 rule. I just did that 2x2 rule down here too. Down here too. Does there have to be a number in every region? The given number indicates how many cells in this region contain a number, at least one. So we have to have at least one in every region, I think. The Smith presented a blocker. Yes, let's do yes'm. Let's do the smaller cued beads. And sling at analyst. We don't have to do 3. Let's just keep going on our test plan. So we have to have a 1 here because we got to have at least 1 in each region. And since we could only have at most one number in here, it's got to be here. This region has 3s, and there's got to be 3s. 3 3s. I'm just filling in the 1 blocks. They're all mandatory, I think. Here's a 3x3 rule. Oh, can't have the same number across a region boundary, right? I guess what that means is that this can't be a 1 right here. And this can't be a 1 right here. So we're forced to conclude that there's 2s in here. That's the rule, right? No orthogonal adjacency across a region boundary. Okay, it's working hard. 2x2 rule. 3, 3. These can't also be 3s, and that would violate the 2x2 rule anyway. We could have a couple of different empty spots and have a 1 in here. We can't have 3s in here. We can't have 2s, I don't think, because there's no way to place 2 2s in this region so that at least one of them isn't next to this one. So this has got to be a 1, and it's not obvious where to put it yet. But we could put a little 1 here somewhere. That looks like a 2. I don't know how we're going to remember this. Okay. There could be a 1 right here and an empty spot right here. Okay, we could do this 5 like we did this 5 up here. Again, we can't have all 4 of these be 5s. So one of them has to not be a 5. And then these 2 would also have to be 5s. Because there's nowhere else to put them. A very full area here. Okay. 2x2 rule. We're going to get 3 3s into this with 4, so we can only make one omission. If we put it here, we'll have a 2x2 area of numbers, so we can't put it there. Two by two rule. This can't be a 1 or a 1. We gotta have 2s. If this is a 1, then none of this can be used. We're not sure if this is 2 or 3 yet. This can't be 2s because the 2 would be next to the 2. And the 1 couldn't go here, so it has to go here. We could put a 1 here and a dot here, potentially. If we can't put a 1 here. So it's either 1 and a dot or 2 2s. This one can't be 2 2s because it's 2 next to 2. So it's got to be a 1 and a dot, and the 1 can't be here. 2x2 rule. It says to be a 1. The 1 is going to be in here, but it can't be across this line here. It's going to be right here. There's something about all of the numbers need to be connected to, right? Yes. We haven't used that at all yet. But this implies that we got to get orthogonally connected out of here. This 1 is going to be isolated if we put a dot anywhere in this region. Therefore, it has to be all 3s. And the same right here. We can't put an empty spot here. And since this region contains 2s, it has to be a 2. And now we've sort of saved this one. It's connected to the mainland. Any other places in danger of being disconnected? So we can't put a 1 dot dot. Can't put a 3. We could put a 2 dot 2. We can also do dot 2 2. I'm not really seeing why either of those is better than the others. It might be that in the rest of the puzzle, if we cut this off with dot, then all of this will be broken off from everything else. I don't think that's possible though. This is mi to this. Well, maybe it's if there's a dot right here. That would do it, right? I said mi. It's a concept that it doesn't matter which side you go on, the outcome is going to be the same. It's borrowed from like Go, Game of Go. Is there a rule about no 2x2 empty areas? No. I think we know the rules. We're just trying to decide on this last bit here. Like, if there is a dot here, then there is a line of dots that kind of goes all the way up to here. It would be a danger that you could need to lay a dot here. Oh, I'm missing a 2x2 rule area. Oh, so we can't do 2s here. Not possible, because that would violate the 2x2 rule. So there is a dot here. Okay. Now the danger is starting to become more apparent, right? We can't put a dot here. Can't put a 1 here, a 3 here. We have to put a 2 here. 2 by 2 rule. Okay, there we go. So it was kind of resolved somewhere else in the puzzle. And presumably this last dot is like, this 1 would be cut off from all of the rest of the pieces if we didn't put this 3 right here. There we go. Okay, so we did end up using that isolation rule. GC sling blocks cross store routes. I do not necessarily know what that means. Is that a conversation ID? What is that? Tutor and incremental. Oh, interesting. So it tried to sling it at the concierge in the rig, and it's not a rig. Maybe it's now it's writing its memories like this. Maybe we should let's go find that memory. Where's it doing that? Cross store sling routing. Yes, I guess we're here. This isn't quite right. You think it's in the mayor's? It's not in the prompt MD. Maybe it's in notes. No, those are the notes files that existed for each one of our agents. And there are still some that are still relevant, right? Like department onboarding, the GC Oracle, concierge. These incremental ones can all get iced, I think. They've all been migrated over to the rig specific agents. So where is this thing? I used to have an alias for this. I should put it back. Feedback cross store sling routing. Oh, oops. Where's it putting this note? I spelled it right, right? We're doing that to not use globs, but I think this would actually look for this character asterisk in the name. I'll just ask it. Maybe let's try one more thing. It's what does it do? Oops. Tried to use the tmux binding to scroll back. Okay. Where are they? I mean, I'm sort of worried about piling up all of this stuff, but that's funny. This happened to me once. It was like it could remember beads, but it would remember all the other stuff that it needed to. It couldn't remember anything else it needed to remember about being my mayor. So, we definitely try to avoid like compaction because of stuff like that. It should really like re-prompt the mayor, just start over. Okay, let's just try it. What's going on here? It's remembering some really weird stuff here, in my opinion. Right? Like some of this is like core critical weird stuff. Um, so you don't forget how to use beads. And then some of this is like completely, useless knowledge trivia. Uh, I, I admire that it's trying to learn things. We figured out where the memory went. I really do think that the antiquarian should own not just the catalog itself, but its own data model. Uh, about the antiquarian bit, naturally own the data model of the product it maintains, the catalog. Um, is the charter not written to allow the agent to make that level of decision? And manipulate. Maybe that is another. Um, maybe that is another thing to add to general department charters. the idea that you own the products that you make, that you are responsible for evolving them as needs evolve. Again, I'm sort of like applying a certain human model to this notion of departments and companies and things. Okay. Right. Yeah. So we haven't talked about this topic in general in these videos. Um, this is the subject of I'll reference Steve Yegge again, one of Steve Yegge's famous platform rants. It's about APIs that break and APIs that don't break. And the idea of an API breaking is the idea that you depend on a service, you call it a certain way, and it does a certain job for you. When I say you call it a certain way, you pass it a certain set of inputs that are standardized by the API, the service interface, or the programming interface, if you want. And the API kind of says, if you give me these kinds of inputs and you call this function, then you get this kind of result. And if you want to create something on top of that API, you want to get reliable responses from it like that. And you want to depend that it's going to be there. And if you can depend on it, then you might weave it into the product that you're making. There are lots of different APIs. I mean, as many as you could think of. Almost any idea that you think of could kind of turn into this question and answer kind of format, right? Or it could turn into a sort of like command and execution is another way to think about it as well. So not everything fits into this pattern. It is kind of a request response pattern I'm talking about, but a lot of stuff does. You could also imagine like instead of making a request and getting a response, I cause an event to happen, and then that event has a chain reaction in some other system, and then there are chain reactions off of that, and that's a sort of different way to do things than request and response. Um, there's a sort of fire and forget, which is sort of like a request without a response. Anyway, lots of different. You can kind of ring the changes on this kind of metaphor, right? But say that you have, built your world around getting a certain response from a certain service. I built my, what to do in my town app around a call to the National Weather Service that says what the weather's going to be like today. And for some reason, the National Weather Service changes the things that are needed, the shape of the input, or how fast I can call them, or some other thing, right? And so the call that I was making yesterday to get the weather doesn't work when I call them today, right? That's a breaking change. And Steve Yegge's platform rant goes on at some length about this, where he talks about how Amazon makes APIs that don't break, that are backwards compatible, going back for years and years and years. And that causes a lot of loyalty as well as reliability. And it causes them to think deeply about APIs, to make long term commitments to them, and so to create them minimally and carefully, and only expand them when there's a real need to do so. Um, the other thing you might say about a breaking change is that they just never wanted to make a breaking change at all. And you would only really do it if you were like, hey, I really need to shut down this service. It's costing me a lot of money to keep it running in its current format. We have a newer, better one. Please migrate to the newer, better one. When everyone stops using the old one, I'm going to shut it off. And we'll also set a deadline in the future. And if you haven't migrated by then you're going to break. But you can see how you could kind of bend over backwards to make sure that your customers had as much time as possible to migrate to the new service, and then to you know go on with their life and not break their what's happening today app or something like that. And he called Google on the carpet for making a lot of breaking changes to its APIs that require customer migrations. And it's there's a huge contrast between those two kinds of systems. Right? And ideally, so there's a lot of ways to avoid making breaking changes. One is to make all the new stuff optional, right? So if you leave the original service call alone, but you add some optional fields, and if those optional fields are used, then you might get a different, better behavior. And that's why there's sort of a carrot and stick kind of thing going on here. And the carrot is if you migrate or if you add these new fields, then it will go faster, or it will be more robust, or it will offer you some new capability, or give you back a richer response, or something like that. Um, and so, what it's talking about is this exact thing. Why do breaking changes need consultation? Well, you need to contact all of your customers and get them to migrate or stop calling you. And if you're going to break somebody, then you shouldn't do this forced migration. Uh, you shouldn't break things in production. You shouldn't like just switch something suddenly and cause my what's happening today app to break for my customers. Um, yeah, you have to communicate them slowly. And so, in fact, we would just every department at Amazon, roughly, I'll say Amazon, but a lot of places, anyone who is a service owner, um, you would try to avoid breaking changes as much as possible, because the more people are using your service, the more valuable it is, the more painful a breaking change is, because you've got to get everybody on board and you got to migrate everybody and you got to track a migration in a spreadsheet and call people because they're not migrating yet, and when is this going to be done? Your skip level manager asks you, and you're like, well, I don't know. There's these 5 other teams that haven't migrated yet. It's a hassle. And so, what if you just keep on adding, accreting stuff like a coral reef onto your API? Maybe you don't change an old call at all. Maybe you don't add optional parameters. Maybe you just add a new call. And those who want to use it, use the new one. And those who want to use the old one, use the old one. And again, you're sort of like, well, there's some benefit to using this new one. Maybe it just opens up this new vista for you. Okay. And the other sort of weird part about this is that sometimes you don't have the benefit of knowing all of the people that you're going to break if you change one of your data types or you change one of your APIs. And that might be because you don't know all of your callers, or you don't know all of the ways that your data is being used downstream. Maybe it's flowing into some data pipeline, and it turned out that somebody depended on a certain field being there that you remove or change. Or worse, silently change the semantics of. while leaving the data type the same. That gets weird. So that so that the software doesn't break, but the data starts getting misinterpreted. Bad stuff, bad juju, right? And so it can be difficult. If you're in a request response situation, it's a little easier. You look at your service logs and you see who called you, and then you call all of those people on the phone. Still not fun. Now, this is an interesting thing. Now, it's true that if there were cross-cutting governance issues, like an ecosystem of things that depended on the catalog and that kind of stuff, um, then maybe you would want to get in a room with everybody. The mayor would look at everything in our model, but sometimes it would be like you could say like a cross-team initiative if you want. There are other terms for it, like jargon terms that were used in different companies I worked for. All right. Yeah, I do. Yes, file. Yes, to expand on the principle, APIs should rarely break their customers. Customers. Additional fields should be optional, and additional service calls can be added without breaking the major version of the API. Old calls may be inferior, but they continue to work as originally designed. Under this model, breaking changes should be rare, and departments should mostly be in control of their API evolution. Cross-cutting governance issues, such as a data type that is used across the ecosystem, would cause a discussion among stakeholders in the human company. Escalating it to the mayor is a potential scenario, or we might be able to design a colloquy. I think I spelled that right. Environment for the different departments to weigh in on such an issue. Such as needing to break a data type that's used. Okay. Somewhat modeled after this kind of stakeholder discussion. As we mentioned, migrations can be expensive and need to be tracked across departments in the human company. but it might make sense to kick across departments in the human company. Sometimes such an initiative is managed by directly. Here we go, man. We're just teaching it. Again, we're speedrunning the evolution of the software industry. Who would coordinate all this activity? We don't exactly have this role in our city. But we could consider that a future. Yeah, I think the idea of making your robots show up to a meeting and argue about stuff. You're like, can we just get rid of all that thing? I thought we had a bunch of robots. We don't need to, do we need to recreate bickering? Is that really productive? I don't think so. All right, I think we finished Nando. I'm not really sure what this would mean. N-A-N, none. I think that is used for number sometimes. It might be short for Japanese for number. But then the do, I don't know what it would be doing here. It could mean a lot of things. Nando. I don't know. Your guess is as good as mine. I could put it into the dictionary. Nawabadi. Territorium. Oh, okay. This sort of looks like a... Interesting. Divide the grid along the grid lines into rectangles. Each rectangle contains exactly one number. Instead of the area, the number is how many edges of the cell are used by rectangle borders, including the edge of the grid. Oh, okay. Oh, no, they're slither link numbers, and they're partitions. Okay. All right. Okay. All right. Let's give this a shot. I said slither link numbers, but I mean this is slightly closer to like Palisade, which the Japanese name escapes me at the moment. Okay. So, we definitely can't have more than one number in a cell, and we need to have 4 lines around the 4s. We're not sure which one of these 3 is open yet. This is a 3 including the grid, so it could go this way or that way. 4, 4. All right, so it's got to be either this one or this one. It's interesting how much open space there seems to be. Okay, so for instance, It kind of doesn't say this, but the way that it works in Palisade is that there are no dangling walls. Every wall in the puzzle is a border. Okay, this is 3 on here. So this is part of this region. So this has to be walled off from this other one because they can't be in the same region. Okay. So where do we go from here? We know from this one. Okay, well, here, let's go like this. We know that these two are kind of together, and so this has to be walled off this way. These two are together. We know that this is part of this region, and these two regions are next to each other now. So we have to wall them off. Same with these two regions, they're next to each other. It would be nice if we had a better way to depict that, but so this one, it's next to this region. Here. This one. Does every region need to have exactly one number? Is that a rule? Yeah, it's rectangle also. So they can't bend around. That's going to be important. I gotten all kinds of grief when I felt like I didn't have the advantage of this rule. Okay, so for instance, this one can't bend around. It's a rectangle. Every rectangle must contain exactly one number. So, all right, let's see what it said. Much firmer commitment to backwards compatibility. Yeah, I mean, this is my Amazon teaching. My this was drummed into me. How about that? Um, I mean, this is the kind of principle that if I were saving nuggets of wisdom, I would save this one. It seems more generally applicable and important. Now, I'm not sure if these are strictly speaking concierge things, because concierge is just to route stuff, right? Weird. Sure, let's see if it does bounce. everything everything closed. Again, can I spin 6 plates at once? I mean, sort of. Yeah, I'm not surprised that concierge escalated the charter beads back to the mayor, because it's not really its job to do things beyond routing. Hmm. it was still writing, I guess. Okay. Interesting. And again, it might be that we're just a little bit behind. So we might want to go read Gas City issues about this. This is interesting. I hope it's specific to this prototype. It kind of seems like it would be. I'm just sort of reading through this and I sort of get it. It's not possible for it to fire at 4x4. That's interesting. Note that we might have a GC issue related to this topic. It's a fast-moving area, I think, is this sort of message I kind of would want to send here. When we're investigating upstream, it's good to see how out of date we might be and to check for related issues. Maybe that's something that the GC Oracle should know. Okay. Again, I don't want my mayor to just have to know all this low level stuff about Gas City code or internals or development practices. I just wanted to consult with the expert. Like, if I can teach this mayor to delegate, you know, it's hard because it can do everything. It can recreate the world from scratch. This has to be something, right? This can't be closed off. We sort of got these dead end ones, right? That I'm sort of saying this is part of some world. It's kind of like Palisade, but it's a little bit different in an interesting way. Since there's one number per, oh yeah, and rectangle. Rectangle is the word here. Rectangle. 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 Yeah, this is working. Rectangle. There we go. We had to do this because we have to get a number in. And it so happened that when we stopped, we hit sort of the butt end of the rectangle. A 3 implies a x by 1 rectangle because there's only going to be one opening. Ah, this is interesting on the 2 too. It can't turn around the corner. It's a rectangle. Got to be at least to here. And now look, that created dead end. It's got to be a rectangle, and there you go. We don't know how far this 2 rectangle goes. We haven't seen any 2 by x rectangles, but oh, well, I guess this one actually has to look like this and this. And you see how it comes out this way? It's a rectangle. It has to come out like this. And then it can't go any further because if we tried to go further, then we'd have 2 numbers inside of our rectangle. There we go. Can't turn around a corner. There we go. Okay, now I'm seeing the sort of forcing nature of all the stuff that we're doing. The weird area is this one, I'd say. Because I mentioned that all 3 rectangles are 1 by 1s. So the only one that can reach this one that's actually looking at it is over here. Right? Because this 1 by 1 rectangle, it can go as far as this. This one can go this way or this way. This one can go this way or this way. This one can go this way or this way. So this one actually has to be linked back all the way over here. It's the only way to get coverage. These can't intersect. And these can't intersect. Like this. All that was forced. This has to come up like so. And there you go. Okay. Then these two, they're sort of butted up into each other. There we go. All right. So far, so good. With this line, there's actually no other way to get to here than from this one to the right. And there we go. We're done. Okay. When we remembered they were rectangles, everything became suddenly clear. How is Claude doing this session? See, this is it's here, it's wrong because upstream is the right one to base the fork on. Yeah, I think you're doing good. No. Okay. Let's make a little correction. Um, the local repo is based on which is a fork of the community project. The fork is probably out of date. I wouldn't expect you to know that, but I would expect the GC Oracle to be able to reference that fact. Probably out of date. The canonical project is on the upstream. In our Git repo. All right. Let's see if it takes the hint and doesn't try to remember this, but tries to see if the GC Oracle has got that in its pipe. Nori. I think we did this one already. In each region, black and two cells, each one is part of a domino. Two dominoes may not be orthogonally adjacent, but they can touch on diagonals. Did we do this one already? I mean, they do all start to kind of blur together. Now, Nori, I know as the Japanese word for seaweed. But I think it's hard to know. There are a lot of homonyms in Japanese, and so um, and, this isn't a perfect system because it doesn't capture all the Japanese words. I don't have a dictionary right in front of me, but I do have a kanji dictionary with the most common ones. Yeah, see, Nori isn't in this dictionary. Maybe it's just spelled out with hiragana. Hmm. Again, captured for future sessions. It's remembering this trivia, and we're going to have to think twice about how that works. Um, we saw what beads memory does. It puts trivia into the beads priming of the mirror, and we have another memory system, which is the cast memory system, and we could tell the mayor, hey, I like what you're doing with bead remember. Now forget it and stop doing it and start using the cast memory system for yourself. Make your own reflections, add your own memories. Make that part of GC handoff too while you're at it. When I tell you to hand off, then first you do all of your sort of reflections and lessons learned, and then you can do your GC handoff as normal. Um, um, sure, it's trivial to update the fork and pull it locally. It's less trivial to build Gas City and then restart, but it can certainly be done. In fact, why don't we just do that while we're thinking about it? Five days old, maybe? Is that what I read? Now we're getting stuff from 7 minutes ago. I know this seems weird to be we've manually sync tags. Okay, so we probably want to push origin tags also. Let's see here. Yeah, okay. It'll make the computer a tiny bit busy, but I don't think we've usually felt too much pain from doing this. We just saw this. We've been syncing tags from upstream. There we go. But yeah, we've been syncing tags in the command line, and we hadn't pushed them out to the remote. So that should be fixed now. That's up here. That's a little better. I mean, we've been doing pretty fine with favicons and things, but okay. Now that we have those, we should have Yeah, we don't need to create our own releases, but we've got the parents tags and things. Okay, now it's working hard. Okay, we've got building Gas City. We've got a couple of GC Oracle questions. We've got the Smith actually doing our 4x4 slither links, which we were using to vet out this artifact versioning refactor that we were doing. Okay. 2 upstream PRs in flight address most of our pain. Hopefully. Probably. It's again, it does seem to have problems with, like, I would say synonyms, or like maybe you should say homonyms instead, actually homonyms. A word being used with 2 different valences. And so it makes a lot of assumptions about like it must be if you see the same word twice in the same discussion, then it's got to be the same. Here I'm just filling in. Remember, we've got to have dominoes can't touch each other on the faces. We've got to have 2 filled in cells per region. And these had only 2 cells in their region, so they're definitely themselves the domino. Here we've got to make a domino, and there's only one direction to go. And same with this one now that we did that. And now we're just filling the last one, the region. Only one way to go for this one. So we're going to make a domino this way, and it can't touch this square. We need to get 2 into this region. We need to make a domino, so we can't make 3 in a row. 2 in the region. Make a domino. 2 in the region. Make a domino. Can't touch a domino. 2 in the region. Make a domino. Let's see. Make a domino. This region's full now. 2 in the region. Yeah. Next to a domino. Make a domino. 2 in the region. Can't make a domino. And there you go. Yeah. Fairly simple. I think once we got rolling, it was hard to stop. We were over halfway. We must be over halfway. More nerdy. Nerdy bow. Okay. Blacken some cells. Okay. Orthogonally connected white cells. And they must not touch each other orthogonally. Cell with the number is always white. Each white area has exactly 1 field with a number. So you can't have a white field that doesn't have a number. The black cells are horizontal or vertical stripes. Okay, this is the big difference. If 2 stripes are diagonally adjacent, they must be of different length and exactly 1 cell wide. Okay. So yeah, it's much like Norikabe, but with these differences. are we doing here? Hmm. Upstream pairs in flight are open and not merged. Hmm. I really, really, really. Oh wait, order tracking feeds? This is a little different. I mean, I don't want to lose any history in the city. That seems like super crazy. But this is a little different. This is about order tracking, orders being scheduled formulas. A lot of this is gobbledygook to me. I think that it's sort of like when I asked it to talk JavaScript to me, and then it started becoming an expert immediately and outstripping my expertise, almost you know using acronyms I didn't understand and stuff, which to a practitioner would be helpful and definitely the way to go. And to a person who is, I'm not really even cosplaying as a JavaScript expert, right? I'm cosplaying as the head of the company or something like that. So, yeah, there was no way that I was going to get value out of those kind of jargon laden discussions. And this is like that. Mm. Okay. Explain the it seems like it is for a policy for specific kinds of beads. There are a number of kinds I think we would all want to retain, potentially forever. But order tracking seems to be in its own class. If I understood why they were there, I would understand if we could get rid of them. A classic. Chesterton's fence. Yeah, this is a you could say a principle of conservatism if you want. Not exactly political conservatism, but sort of like philosophical, if you want. Um, and the quote from Chesterton, G.K. Chesterton, is something like, if you can tell me why the fence is there, somebody wants to remove a fence, right? They come to the city council or something like that. And the city council asks the reasonable question, why is the fence there? If you can tell me why the fence is there, I might let you remove it. And so, right, it does kind of create a presumption that things are the way they are for a logical reason, and that those who want to change the way things are need to overcome that barrier, right? And so yeah, it does bias you towards, well, everything is the way that it is for good reason. It's a sort of trust in systems or trust in traditions, right? And so that's why it gets associated with, philosophical conservatism, or you say conservatism. Is that how I'm supposed to say it? But you could say that political conservatism has a lot to do with this too, right? It's like, you know, surely our parents wouldn't have taught us the old way for no good reason. you know And there's this kind of chain that goes back forever, right? And so you can ask, well, why do we change anything? And I think that the reason is, we're going to make it better, essentially. All right. Let's see what it gives me back. Reading some source code. All right. Here's our nudity cave. Remember, our our black areas are 1 by 1. Um, and if they touch diagonally, they need to be of different, or 1 by x, 1 by n. And if they touch diagonally, they need to be different lengths. So far, we have a little issue. Oh well, this one is fine because we can't put an X here. It would cause this water to not be rectangle. And then we've got this one. Again, we can't put it here. It would cause it not to be rectangle. Cause not to be rectangle. So here we can apply our rule. If they're connected diagonally, they need to be a different size. So this is a 1, and this one can't be a 1. It's got to be longer. If they're 1 by x rectangles and we know the direction of the rectangle, then we know stuff like this. Like there has to be island next to the 1 by x strip of water. We could connect up this island, but that would cause a bunch of x's. We have to think about whether we can support all of those x's. And I think the answer is actually no. I kind of did this in my head, but check this. Check these x's out in the middle right here. We can't connect these x's up because we'll make non-rectangular x's. Same, same. Now look what happened. We've got two x areas that are touching diagonally that are the same size. So the hypothesis that this was island and made the final 7, right, that had to be surrounded by water, it's not the case. It has to be water. And there's no way the 7 could wrap around over here, so it's probably going to hit this 6 here. Where do we go from here? I guess the border between these two islands has to be a rectangle. And I mean, I guess we could kind of carve out bits of it from the bottom. Does the black water all have to be connected? It doesn't say that. Every white area belongs to a field with exactly one number. Okay. All right. Cool. Let's learn something. Controllers mechanical orders, each firing a tick. We get obeyed that has a label, order tracking, and order run, and etc. They are not user work. They're bookkeeping rows that the controller uses to remember that this order ran and finished. They persist for cooldown gating. When order fires, a bead is created with label blah blah blah. It finds the most recent run. It's supposed to be rate limited. Okay. After 7 days, right? We don't have anything running on a 7-day schedule. Okay. Okay. Only order tracking. Real work is retained indefinitely. Sure. Now that I understand, 7D seems fine. We're not going to remain interested in this detail or in this implementation detail for even that long. Excuse me. Good. Max depth 3. But no, it's like they're right there in the directory. Depth 1 or even 0. We'll commit this change, but I don't think the city is running with it. It probably reads this configuration on a GC restart. Yeah. Yeah. Let's wait. Let's wait until natural rain. That's fine. All right. Hmm. So we either have to stop here, this water, or keep it going twice. We need to separate this 9 island from this 6 island. I mean, the 9 island takes up a lot of room, but it's not exactly like forcing in this scenario. Like just to give some idea of how big the sizes are we're talking about here. So this is an illegal solution because we have this black water that is, you know, not rectangle shaped, but this gives you a sense, right, of about how much room these things are going to take up. And the reason I'm doing this is I'm trying to get at the idea of what ground needs to be covered. The sort of weird area is up here still, right? Not a lot of stuff is reaching up there. So it would be possible to cut this off right here. We sort of want something up here, right? Like you can imagine if we kind of went up this way. You see how that's extending the 7 island? 1, 2, 3, 4, 5, 6, 7, right? Then we have to do things like this. See, it's not quite right. And so, but we're just sort of trying to find where to put pressure on the puzzle. or where the pressure is coming from. So we'll do things like this, for instance. And we'll say, okay, well, that means that this set of water is going in this rectangle, and this is island parts. Definitely can't be part of the 6, because it would take us 2 cells to link up all these together, and that would make this island at least 7 cells big. So all of this isn't going to connect to the 6. That means it's got to connect to something. It can't connect to the 7. It would have to, and it can't, the 6 can't reach, so it's got to be the 9. We would also note that we can't put this water can't stop at 2 because it's diagonally touching a 2, so it'd have to go up still further. So now the shape of the 9 area is getting a little wonky, perhaps. Got to get out here. The shape of the 6 area might be okay if we went like this-ish. We go out this way. So far, everything I'm doing is legal. Then we'd have we have to keep this in a single file, and so we'd have a 9 that kind of looks like this. Now we could start talking about how there's no way for any of the islands to reach this corner. Right? The 7 can't get to it anymore. If this isn't part of this 4, or in a sort of like long line of 4, then it could go this away. That would mean this would have to be island, and however far out we go, this would have to be island. So like, again, there's sort of a bifurcation of worlds here where we kind of look at this. It's interesting that in both cases this is empty still. In this world, we definitely have to make it look like this, and this would be a violation because we'd have to have this 2 next to this 2. Oh, it's a 3, I guess. No, it would be okay. Let's see. In this world, we'd have it like this. Note the interesting fact that there's this again. It's in both worlds. 6, 7. And we don't know if this is part of an island or not. This is just sort of a possibility that comes from this being an X right here. 2, 3, 4, 5, 6, 7, 8. So we could connect this all up and make it one long island, but then we'd have to do some kind of funky stuff with next to, and see, this doesn't work. This would make like an X space that's not just a single file rectangle. When did that happen? Oh, it happened, right. It happened because we put this in here. So we'd have to go like this and this and this. We'd still have to lay down 3 cells for the 9, and we still have to lay down 1 cell for the 6. And between those two things, we have to be able to fill in the rest of the map with yeah, I don't think I can quite make it work because I mean maybe. But anyway, yeah, we kind of got on this jaunt because we we're like I think 2 hypotheticals deep now. And while that is appropriate in a certain, like, it might be the only way to go sometimes. um Not the funnest way to do a puzzle. It makes me feel like we're missing something. I don't think that mostly they're designed to be like this. Like, I have some very hard puzzle games I enjoy that are like that. Okay, it's just waiting there. I find it hard to believe there's nothing else to do in the city. But maybe that's my cue as well. It's been fun. We'll keep trying to push things forward. I know it still feels like a slog, and we haven't even quite integrated the Gastown pack yet, but sooner or later we will get there. We will figure out everything that's there is to be figured out, and everything will run like clockwork. Right? We'll see. Have a good night.